Hello everyone. Today we will start lecture 15 of module 5, that is on flood studies. So this is the first part of lecture 15. So you might have heard about the Planform, right? It is not platform, it is Planform. So the Planform of a river channel signifies the top view integrating plan features like straight, meandering or braided channels and fluvial reliefs, whether flood plains, flood channels and low water channels. So basically we are looking at the river system from the top, right? And then we try to see the area and then we try to quantify it. So that is known as planform evaluation of the river system, right? When we talk about the planform studies, we have potential application of remote sensing data set, because from remote sensing we can see the entire area together captured at the same time, right? So here we will see some of the examples, like whether the system or the river is sinus, whether it is a meandering river or whether it is a braided river, right? So one example of sinus river is the Mahanadi, right? And the meandering river is Ganga, and the braided or highly braided river, that is the Kaming. It is part of Brahmaputra, right? And we all know that flood affected areas can be easily identified using the remote sensing data if we have pre and post flood event data set. Here also you can see that flood affected areas can be easily demarcated, right? So this is what we can do and why we are trying to learn what is the potential application of remote sensing in planform studies, right? So here visually it is very clear that all these boundaries are for the river. This is maybe the flood affected areas, right? Here also you can see that this is the main channel, right? And this is the floodplain, right, this white color. So visually it is very clear, but how do we actually extract this information? Because we need to quantify in some numbers, right? So we will learn today how remote sensing data sets are being utilized in deriving the information for any given river system, right? So here before we continue this, we need to learn the data type. So if you remember that I have already discussed this data type in the beginning when I was covering the remote sensing. So here you can see that we have two major types of data set. The first one is the raster, where the images are generated and it is divided into pixels. So the grid cells or pixel or the elements are present and they divide the area, right? When we talk about the vector, we have point, line and polygons. So here you can see this is one type of polygon, this is another type of polygon, right? But if I draw a line here, this will become a line feature, right? This is one point, this is another polygon, this is another polygon. When we want to precisely define the boundary of a particular object, then we use polygon. If we want to delineate the roads, then we will prefer to use the lines. If we want to demarcate the center line of a river, then we will use the lines. If we want to demarcate the boundary of a river, then we will use or we will prefer to use polygons, right? So we have also learned about the raster data. So the area divided into pixels, it stores images as row and columns of digital number for each pixels. Then digital output of any camera or sensor is a raster data. So, all the satellite images are raster data, right, satellite images. Based on the map scale or spatial resolution, each pixel represent the area on the ground. So, if you remember that I talked about one detector of a particular sensor is looking at the ground and it is covering a particular area. So, this area will become the spatial resolution of this particular sensor, right. So, if it is 30 meter by 30 meter, then that means this particular detector looks at the ground and that area is basically 30 by 30 meter. It is very useful in representing the continuous variation or thematic or dense data set. So, if you have continuous variation, so I gave you one example that if you take boundary of the lake, this raster data is not a good option. Why? Because if the pixel is like this, then here half of the pixel will be land, half of the pixel will be water. So, depending upon the spatial resolution, we decide whether lake can be represented by our raster data or not, because the area will not match with the actual area. It is a very simple data structure, but requires large storage space to store these data set. Commonly used data formats are JPEG, TIFF, GeoTIFF. So, these we have already learned in the beginning of this course, right. So, why I am referring it again? Because now we will be actually using it for deriving or extracting the information for our river or fluvial system. So, the vector data, the simplest element is the point. Here you can see. So, this point can be confluence point of a river, right, where tributaries are meeting. So, if you want to highlight that particular thing, then you can use this point. Then line, a set of connected points, because here these will be connected and here these lines are used to demarcate the boundary. Then comes the polygon. If a river is wide, then one single line is not enough to demarcate or represent this river. So, what we will do? We will use the lines both side and then it will become the polygon. So, this whole river system will be represented like this. When we talk about the vector data, so the area separated with different polygons, here is the example. Statistics can be estimated for the individual lines or polygon, because each line and polygon have different characteristics. So, the length, area, perimeter, these things can be easily estimated for each of these features. Very useful in representing the discrete data. The discrete data is the data which has the defined boundary, which we can easily identify that this is the ending of this particular feature. Many attributes can be associated with each polygon. The attribute we have discussed that for the same point or line or polygon, we can have multiples of information collected in the field or collected from various sources that can be stored together. And because of that, it is having the complex data structure, but it requires very less space to store, because everything will be stored in the form of ASCII. And using this data type, we can represent our object very nicely. Now, when we have satellite images, how exactly we are trying to extract these information, that we will see now. So, let us say this is one satellite image, this one. Now, you open this in ArcGIS, QGIS or any other GIS software, and all the GIS software have the option of digitization, right. So, once you open this, on top of that you can create a layer of vector and then you can start digitizing. So, once you start the digitizing, then this kind of map can be prepared. So, let us say that this is the channel. So, I am going to digitize. So, depending upon my accuracy, this data will be generated because this is the manual delineation we are talking about. So, it depends upon my accuracy, how accurately I am digitizing this one, right. So, if you see, I have missed many points, right. So, here we are generating this vector layer using the polygon, right. So, like this you will digitize and then you will generate the vector data for your river channel, right. Then I have to close this one and then close this one, because then it will become the polygon. Now, if you see, this is representing the water channel of this particular river. Now, if I have to demarcate the boundary of flood plain, then I have to use this, right. I have to demarcate this boundary, not only the water one. So, this will become the flood plain. So, this flood plain helps to restrict the flow of water during the flood event. So, they also accommodate some amount of water. So, that will help to reduce the discharge at the lower reaches, right. So, using this particular method, digitization, you can see here this map has been generated, right. And once this map has been generated, you can easily calculate all the parameters like area, perimeter, distance, all these can be easily calculated. This is another example of vector data which is generated using the raster data. This one is the another one where this has been overlaid on the satellite image. So, information on stream, river or fluvial systems is being generated using geospatial technology for further studies, because now we are talking about the planform studies. So, first we need to have the data, then only we can talk about the methods, right. So, I thought of giving you this brief introduction in the beginning, so that you will be able to understand how remote sensing or satellite images or UAV images are being used in the planform studies. So, once you have this data, then you can calculate area, length and perimeter. Now, once you have this, then you are ready for the analysis, right, because for each of the polygon you can easily calculate the area. If this is, let us say, one river, right. So, you can also digitize the center line, which is the main water channel for this particular river, and you can calculate the distance from here. So, the length will become the distance between this and this point. Now, the aerial distance between these 2 points will be this, right. If this is the flow of water, then this will become the center line or the water line of this particular river. So, this length will be something like, let us say, 300 kilometer, but the aerial distance between this to this will be approximately, let us say, 250 kilometer, right. So, the 50 kilometer is more because of this undulations, right. So, this kind of information will be extracted. Even we can calculate what is the number of first order channel, second order channel, that it is very clear from these maps, right. So, all these information will be extracted from this layer and then we will be using it for planform studies. So, before we start the planform study, let us understand the geomorphology. So, geomorphology investigates the landforms and processes that fashion them, right. So, here we try to understand, we try to study the landform and the processes which are involved in shaping them or developing them, right. So, here some of the examples are there. So, this is one landform, this is another landform, here you have another landform, right. Here you have another landform. So, this comes under the geomorphology. So, since we are talking about the river or fluvial system, we will focus on the hydrogeomorphology. So, the hydrogeomorphology designates the study of landforms caused by the action of water. So, here we only consider the water as an agent which is responsible to shaping the landforms, what we see today, right. So, here you can see this particular river channel, it is eroding, because of this the shape is like this, right, isn't it. So, here everything is because of the water. Here this you may consider this is a floodplain. So, hydrogeomorphology is an inseparable part of geomorphology, as water is one of the most important agent in forming and shaping landforms. So, here you can see these landforms are shaped because of the action of water, right. So, anthropogenic activities like man-made or the human intervention, the river regulation, sand mining, these are gradually increasing, because slowly we are having more requirement and we are extracting the natural resources, and that is disturbing the natural setting of a fluvial system. So, which are gradually disturbing the natural form and processes of the river. So, what we see today, it was supposed to be because of the hydrogeomorphology, right, because of the action of water. But since humans are very actively engaged in disturbing these natural resources, because we also need resources to sustain on this particular planet. So, because of that, whatever we see, it is not only because of the natural water action, but it is also because of the anthropogenic activities. So, that we need to understand before we begin, right. So, when we talk about the Himalayan river or any river system, you see the water is originated at the snow or glacier level. So, let us talk about the Himalayan rivers. So, here this is the source of the water, right, and rivers and stream works together as a fluvial system, actively shaping the lands by eroding, moving and depositing sediments. Now, because of this erosion, transportation and deposition, these landforms are being created. So, let us see some of the photographs that I have captured in the field. So, this is at the glacier level, from where the water is generated because of the melting of the snow glacier. Then slowly it is flowing towards the low lying area, and with the slope it is, and because of the action of water, these valleys are slowly created, and you can see how the water is moving in this particular region, and then slowly it is reaching to the plain land, right. So, here we can understand with our history that rivers are the lifeline for the sustainment and development of the human race. So, rivers are lifeline for the sustainment and development of the human race, because we need water to sustain on this particular planet. So, the quantification of such fluvial alteration is essential for a sustainable river restoration and management program, because we need to quantify, then only you will be able to utilize this information in the river restoration and the management program if required for a particular area, for a particular fluvial system. Till 1980s, the flow and the sediment quantification were based on hydrological data. It was purely based on the in situ data. The geomorphological studies were carried out using maps and toposheet. It was very basic. So, started because geomorphology was evolving. So, subsequently it became the quantitative geomorphology, right. So, now if we see the 1980s era, then maps and toposheets were the main source of the information. After 80s, the remote sensing was introduced. We had a few satellites and the remote sensing data sets were used, right. And then subsequently new developments in data analysis and interpretation that were started, which led to new research on large rivers and to supporting the integration of geomorphology and ecology, right. So, this is what I wanted to convey, that in the beginning we were only using the maps and toposet for the geomorphological studies. Now, because of the advancement in the technology in terms of remote sensing sensor and the analysis technique, now we are moving ahead and we are doing more quantitative geomorphology, and in this case it will be more quantitative hydrogeomorphology. So, this particular figure shows major Indian cities on the bank of the Ganga and Brahmaputra river and their tributaries. So, it shows or it proves that for our sustainment that we need water, and we only started our civilization along this river channels, right. Now comes the channel planform. The planform of a river or channel signifies the top view integrating plan features like straight, meandering and braided features and fluvial reliefs, which is floodplain, flood channels and low water channels. Combinations of these categories define the diversity of pattern, because we do not see the same a type of feature in all the river system. All river system have their different patterns, right. Stream power signifies kinetic energy associated with flowing water. This integrates channel bed slope and discharge. So, now the bed slope and the discharge, that is integrated into this analysis. The critical stream power and the hydrological regime together defines the channel pattern. So, now whether channel pattern will be like this, right, or whether it will be like this, it all depends upon the stream power, what is the energy in your water and the hydrological regime, right. So, together they will be responsible in shaping these river systems, right. So, that is why we have started with geomorphology, then hydrogeomorphology, now comes the channel planform. When we see a particular catchment, here you can see different features are mentioned. So, here you have a straight river, here you have sinus river, here you have braided river and here you can see the meandering river. So, this one figure explains all different types of features of a particular channel. It is a schematic illustration of straight, sinus, meandering, braided and anabranching river channels, which some of them are active, some of them are abundant, and their associated levees, bar and overbank landforms. So, it is a very nice representation of all different types of channel patterns, right. Now, let us see the types of channel planform. So, when we see this planform of a stream, it has two types, single channel streams and the multi channel streams. Then for the single channel we have straight and meandering, with the multi channel we have braided, anabranching, reticulate, deltatic, right. Then with the meandering we have two different types, right. So, all these are the different types of planform which you will be seeing in different river systems, right. So, let us see this particular planform. So, this is basically showing the straight channel. So, this is from the Narmada, you can see how straight it is. So, we can easily extract this information and then visually we can confirm this is a straight channel, but to prove it we need some quantification and that we will be discussing in these next few slides. Now here you can see this is the example of sinus river, this is Tista. So here you can see how it is flowing, right. Now comes the meandering one. So here the meandering, the best example is Ganga. Here you can see some of the places you can easily see the flood plains, right. Styles of meander mitigation and cutoff formation, it is from this particular book. So here you can see the Oxbow Lake, the feature, I hope you know about it. Then highland, here you can see the braided example. So this is from the Brahmaputra, this is again anabranching that you can easily see in again Brahmaputra, right. So this kind of flow will be there, two main channels divided and then subsequently they will meet, right. Then from Australia we have one reticulate pattern. So here you can see this is from Mahanadi deltaic pattern. So you can see this kind of feature will be present here and the delta formations are very common and it has been reported in many studies, right. So let us start with the basic one, the meandering river. A meander is one of a series of regular sinus curves, bends, loops, turns or winding in the channel of a river, stream or other water course, right. It is produced by a stream or river swinging from side to side as it flows across its floodplain. So with this I will stop the part 1 and we will continue this lecture in the part 2 of lecture 15. Thank you.